Right, so good day again, everyone. So for today class, we will be discussing about intravenous bolus dose model, multiple drug administration, and the steady-state average concentration. Now, class, of course, this is something that we need to understand because in a clinical setting class, normally when you give a medication, you don't only give it once. Okay, oftentimes class, we give it multiple times until we reach what we call the steady-state concentration, wherein we say that the steady-state concentration should always be within the therapeutic window so that we can be assured that the medication is both safe and effective. Okay, so our objectives for the class are as follows. So first, to understand the concept of IV bolus dosing. Now, why are we choosing IV bolus dosing as a model, as a model to discuss about multiple drug administration and the resulting dose accumulation or drug accumulation in the body? Okay. Well, for one kasi class, mas madaling intindihin ang IV bolus dose. Why? If you give a drug intravenously, the bioavailability will always be 100%. So, kumbaga, if I start plotting it in a plasma level time curve, my Cmax will always be at its maximum. Okay? The concentration class, the initial concentration, what we call the CP sub-zero, will always be at its highest. Okay? If you are giving a drug via bolus. If I give the drug kasi class via, say for example, per oral tablet, diba? It starts with 0. Then unti-unting aakyat. Correct? Its absorption class is relative to its bioavailability. Okay, if this was to be given extravascularly. Extravascular. Ito yung intravascular. Okay? So therefore, class, yung pag-angat na yan, kailangan ko pa i-consider yan sa pag-compute ko. And which, of course, makes the discussion more complicated. So sabi nga, class, gusto nating mapadali, okay, ang discussion natin here. Okay, so that's the reason why we'll start off with IV bolus dosing first. Okay, then saka natin siya gawing komplikado a little bit. Okay, when we start discussing about infusion, okay, and then of course extravascular administration, multiple dosing. All right. For today, let's stick with the IV bolus muna, which is a lot easier to understand. Okay, then second would be to understand how drugs accumulate. Okay, after multiple dosing. Now remember, class. Okay, when do we reach steady state concentrations? We reach steady state concentrations after how many half-lives? So normally that's 4 to 5 half-lives. The halves. Okay, that is the time needed to get to CSS, or what we call the steady state concentrations. Okay, so say for example, class, if a drug has a half-life of, let's say, drug X. If drug X class has a half-life of 4 hours, then a question would be, what time will it take, how long will it take before the drug reaches steady state concentrations? So obviously, class, I'll just multiply this by 4 to 5. So yung 4 na yan, that will be 4 times 4 at saka 4 to 5. So that will give me 16 to 20 hours. Meaning, after 16 to 20 hours of using that drug X multiple times, okay, using drug X multiple times, after 16 to 20 hours, depende pa to kung ano yung dosing interval na ginamit natin. Okay, pero again, remember, dosing interval is almost the same as that of half-life. Okay, so normally after, kung ilang half-lives man yun, after 4 to 5 half-lives, so kung after 4 to 5 doses, usually nasa steady state na yung gamot. Okay, pero in this case, guys, let's just compute just to be safe. So if drug X has a half-life of 4 hours, then if you use this multiple times, approximately after 16 to 20 hours, the drug will be at its steady state concentration. Now remember, what's steady state concentration? Okay, it's a concentration class where drug remains relatively the same. The concentration of the drug, peak and trough concentrations, relatively remains the same. So of course, class, if we are giving the drug multiple times, we want the peak and trough concentrations to stay relatively constant. Okay? And it should be within the therapeutic window. Okay? Yun yung idea natin dito. That we want the CSS, the steady state plasma concentrations, to stay within the therapeutic window. And that's our goal as pharmacists. Okay? Ang goal natin is to design a dosing regimen, meaning the dose and dosing frequency, to make sure that the plasma concentration goes within the therapeutic window and stays there as much as possible. Alright? So, yun yung aaralin natin ngayon. Okay? Pero of course, to understand this further, we need to first understand the IV bolus dosing concept muna. Okay, then explain how drugs achieve steady-state concentration, its application in dosing, conduct computations on dosing regimens given via intermittent IV bolus. When we say class intermittent, ibig sabihin sunod-sunod. May dosing frequency na involved. Okay? There's a dosing frequency involved here. Right? So kung sabihin natin every 4 hours, every 8 hours, every 12 hours, yun yung intermittent dosing. Okay, you're giving it at a constant time, at a constant interval. And apply the concepts of intermittent IV bolus dosing in pharmacokinetic decision making. And of course, at the end of the day, class, actually at the end of this course, yun naman talaga ang goal natin here. Okay, for you to be able to do pharmacokinetic decision making. Okay. So what is an IV bolus dose model? So it's not often used clinically, right? For the main reason, class, that most medications, if you're going to give it intravenously, ang best option would always be an infusion. Okay, ilalagay yan sa swero. Alright? Pwede naman ang push, pero rarely do we do this. Okay? Hindi siya ganun kadalas. Mas madalas pa rin ini-infuse yung mga gamot via IV infusion. Okay? Kaya nga, class, ang next lesson natin is intermittent IV infusions naman. What if I infuse the drugs multiple times? Okay? Pero again, for today, class, we just want to understand the concept of bolus dose model. Right? So it's not often used clinically, but however, it is the simplest example of multiple dosing, okay, wherein you administer rapid IV doses via IV bolus of a drug at constant time intervals. Now, the drug is represented by a one-compartment model with first-order elimination. So when we say first-order elimination, it means the therapeutic concentrations are away, okay, or it's not near the saturation point of the drug. Kasi if the therapeutic concentrations are near the saturation point of the drug, then that drug would most likely follow zero-order process. Okay? Sabi nga na, di ba, the simplest compartment model that we can use to describe drugs' behavior inside the body would be a one-compartment model following a first-order kinetics or first-order elimination. So, let's have here class A scenario. Let's say, class, we administer drug X. Drug X ulit tayo. At a dose of, sabihin natin, 500 milligrams. And at a dosing interval, which is represented, class, by the Greek alphabet tau. Sabihin natin 8 hours. Before I proceed any further, one thing, class, you'll notice about dosing intervals is that a dosing interval, class, should be a number that can divide 24 equally. Okay, you might be wondering, sir, bakit ganon? Okay, the reason behind that kasi, class, is you want a number that can divide 24 hours equally. Okay? Para, class, the time that you give a medication will be the same time you give it the following day. So, halimbawa, binigay ko siya ng 8 a.m. Tapos Q12 or every 12 hours ang dosing interval. So, 8 a.m. ang first dose ko, 8 p.m. ang next dose ko. The following day, 8 a.m. ko ulit siya ibibigay. And 8 p.m., 8 a.m., 8 p.m. sa mga succeeding days. So, the time, class, will always be the same. Para hindi nakakalito sa part ng doctor, sa part ng nurse na nag-administer. Okay, so that they can give it the same time every day. Alright? So, that's why, class, you'll never see a dosing interval na every 5 hours, every 3 hours. Tama, wala nga every 3 hours. Okay, just making sure. Ay, meron. Pwede kasi every 3 hours, pero well, mas common ng every 4 hours. Okay? Tama nga ba? Okay. Tama, 21.7 plus 24.8. Okay. So, mga ganon. Pero, class, again, wala ka makikita every 7 hours na dosing interval. Okay, usually it's every 8 hours, every 12 hours, every 4 hours, every 24 hours. Alright? So, kaya laging, halimbawa, pag nagko-compute kayo, kaya lumabas na result nyo is, give the drug every 5 hours. Ngayon, pipili ka, bibigay ba yan every 4 hours or every 6 hours? Okay? Diyan papasok yun yung decision-making skills ninyo. Which one do I give? Kasi if it's an antibiotic class, personally, I'll give it every 4 hours. If I get a dosing interval of 5, na-compute ko every 5 hours. Personally yun. Bakit? Kasi gusto kong mabilis makapasok si antibiotic sa katawan ng patient ko. I get the maximum dose. I get the maximum concentration at the shortest time possible. Okay? Or, what if the antibiotic naman is highly nephrotoxic? Or alam kong lumalabas yung toxicity niya at high doses. Okay? So, kung like say for example, vancomycin or di kaya aminoglycosides like amikacin, okay, well, class, I'll probably go for every 6 hours na kung ganon. Okay? After I adjust the dose. Kasi ayoko naman ma-expose agad yung patient ko sa toxicity. Baka hindi na gamitin yung gamot. Right? So, stuff like that. Again, class, that's something you develop as a clinical pharmacist. Okay, sa aking class, dito sa subject natin ngayon, gusto ko lang maintindihan nyo na pwedeng gawin yun. Okay? Yung mga ganong klaseng decision making. At yun usually nangyayari naman talaga sa practice. Well, normally class, if you shorten the duration, binababaan din natin yung dose. Lalabas yun sa computation mail, bababa ang dose. Okay? So, ayun. So, anyway. So, let's say class, after I give drug X at 500 milligrams, ito yung kanyang Cmax. Dito yung Cmax niya. Let's use a different colored pen. Okay. And dito yung first Cmax niya. Or CP sub-0. Let's call this CP sub-0. Pwede rin naman yun eh. Or what we call the first Cmax. Now class, I'll be labeling the peak concentrations as Cmax 1, Cmax 2, Cmax 3 because we'll be giving the drug multiple times. Normally class, if you give the drug once lang naman, pwedeng Cmax 1 or simply CP sub-0. So Cmax 1 is equal to CP sub-0. Now, normally class, since this is a drug that follows one compartment model, okay, and it's following first order elimination, so as time goes by, okay, it's going to reach a certain point. Well, actually, any point in the line naman, pwede natin ma-determine yan. Okay? Now, normally class, kung wala kang gagawing iba, right, after giving the drug, you just give the drug once, okay, and allow it to eliminate, then obviously, mawawala yan sa sistema mo. Pero normally class, when you give a drug multiple times, okay, let's say this is the MEC. Okay? If you aren't going to give class a drug multiple times, you don't want the drug to go below the MEC, right? Kasi if once it goes below the MEC, then we lose the efficacy of the drug. Correct? Okay. So therefore, class, bago ma-reach ang MEC, we need to give another dose of the drug to keep the effects consistent. Okay? So normally, class, before you even reach the MEC, anong gagawin ko? Magbibigay na naman ako ng next dose. Alright? Now, of course, class, that next dose will be higher than the first dose. Right? Because dito sa parting ito, may naiwan pang gamot dyan. Okay? So, ang gagawin natin, class, if I give the drug at 500 milligrams ulit, okay, whatever the height of this will be the same height nito. Correct? Whatever the height of this will be, okay, will have the same height as this one. Kasi same dose lang naman yan eh. If I give the drug much lower, obviously, mas maliit yung line na yan. Kung mas mataas naman, mas marami akong binigay na drug, imbis sa 500, 1,000, edi obviously, tataas na ng bongga. Okay? But in this case, class, since we're gonna give the drug at the same concentration, sorry, at the same dose, so it will have the same height. Okay? So anyway, now class, since we already, from this point to this point, from this point to this point, this is what we call your dosing interval. Okay? This was, the dosing interval, class, is the time you allow the drug to eliminate. Okay? You don't want to give the drug naman consistently eh. Kasi, baka mamaya, sumobra naman dami ng gamot, right? Unless you're giving this via infusion. Okay? Pero again, ang example natin here right now is an IV bolus dose model. Right? So therefore, class, this will now be labeled as Cmax 2. Meaning, this is the second time you gave the drug. Okay? And the drug will give this peak concentration. And then it's going to eliminate again. And this will be the new C mean. Okay? So again, from this point to this point, that is another dosing interval. So kung this is 0 hour, this is the 8th hour. Okay? Kasi sabi natin, dosing interval natin kanina is every 8 hours. And then this will be the 16th hour, and so on and so forth. Okay? Now, remember class the equation that we have for first order process, which is C equals CO E negative KT. Okay, remember class that CO or CP sub 0 can also mean your C max, right? So class, and then this C here, this concentration here, can be any concentration along the line, right? So class, this formula here, the C equals CO E negative KT, raised to negative KT to okay? Pwede natin palitan yung, yung variables dito. So instead of C equals CO E negative KT, I can write it down as C min 1 equals C max 1 E negative K tau. Alright? So, kung i-write down ko yan, ibig sabihin, if I want to compute for C min 1, this one, as long as I know my C max 1, I know the dosing interval, okay, and I know the K, elimination rate constant, I can compute for C min 1. So in this case, class, okay, CP sub 0 natin, hindi natin alam eh. So C min 1 is equal to C max 1, tapos E, negative K, whatever that K is, tapos yung tau natin dito is 8 hours. Correct? Kasi tau natin, it refers to your dosing interval. Now, just a quick recap. CP sub 0 class can be computed in two ways. Sabi natin, di ba, this is not a real value. Okay, it's impossible to get actual CP sub 0. So what do? We compute for CP sub 0, right? And there are two ways, class, wherein we can compute for this. I've taught you that from our previous lesson. One class is to use the formula dose over VD. Right? Whatever the dose is, divided by the VD, you'll get CP sub 0, or what we call C max 1. Okay, pwede yun. Dose over VD. Okay, another way, class, for us to compute for this is, we use the equation CO equals C E positive KT. Okay, I hope you still remember this. Right? We can do that to compute for CP sub 0. Excuse me, CP sub 0. Pero in clinical practice, class, to get C max 1, you usually don't even know what the K is. Right? And you don't even know what the actual plasma concentration is right now. So normally, we don't use this clinically. Okay, we just use that in our practice problems. What we use clinically, on the other hand, class, is this formula here. The CP0 equals dose over VD. Yan yung ginagamit sa hospital. Kasi class, alam natin lagi ang dose, right? Yan yung bibigay mo sa pasyente, alam nga naman di mo alam yung dose. Okay, then yung VD naman, class, lagi itong provided sa drug literature. Okay, and the drug lit class will always explain this as liter per kilogram body weight. Like say, for example, drug X, ang kanyang VD is, kunwari lang naman 0.2 liters per kilogram. So as long as you know the patient's weight, you can compute for the drug's volume of distribution. Right? And again, it's normally given naman na class. Given na yun sa drug literatures natin. Okay, it may not be the exact VD for a patient, but it's the VD class na common sa general population. Okay? So anyway, so now, class, we can rearrange the formula like this. So C min 1 equals C max E negative KT. Right? So wait lang, maglinis lang tayo saglit. Let's just clean this for a bit. Okay, I think clear naman na to. Okay, alam naman na MEC yan. And this is CP sub 0. Alright. Okay. Now, class, remember a while ago, before, nung ibinigay natin yung second dose, we had to make sure that there is still remaining drug inside the body. And that remaining drug inside the body should not go below the MEC. Because if it goes below the MEC, then the drug loses efficacy. So before the drug class reaches the MEC, we give the second dose, right? Okay, which led to the formation of Cmax 2. Okay? Now, this is the height of C min 1. Yan. And this is the height of Cmax 2. So, from here to here. So, meaning, class, to get Cmax 2, all you need to do is add Cmax 1 plus C min 1. Okay? Whatever the concentration of Cmax 1 is, just add it together with C min 2. So you get Cmax 2. Makes sense naman, right? Okay. Now, class, anong gagawin natin next? Since this is the formula for C min 1. Ito yung C min 1. C min 1 ang kailangan natin, may formula tayo for C min 1. Right? So, meaning, class, I can substitute this equation here. And ang lalabas dyan, class, is C max 2 is equal to C max 1 plus C max 1 e negative k tau. Now, algebraically speaking, since pareho lang naman itong entity na ito, we can simplify further the equation and make it as C max 2 equals C max 1 times 1 plus e negative k tau. Right? Now, that's for C max 2. Second dose pa lang yun. Sa tingin nyo, class, pag nasa hospital lang isang pasyente, ilang doses kaya ang binibigay natin? Multiple nga eh. So, normally, class, this is what happens in a hospital setting. So, you give the drug multiple times, right? And each time you add on top of the remaining drug inside the body, tataas ng tataas yung concentration natin. Okay? Pero sabi nga natin, class, there comes a time wherein, ito pala yung mga dosing intervals. Okay? There comes a time, class, wherein you start reaching a condition known as steady state concentration. Called that the CSS. And the CSS, class, is the point in which drug absorption is equal to drug elimination. So, equal yung yung pagpasok at paglabas ng gamot sa katawan. Kaya, class, ang nangyayari is, ito yung papasok yung gamot, mawawala. Papasok, mawawala. Papasok, mawawala. Okay? Equal ang rate of absorption sa rate of elimination. So, you get what we call a steady state concentration. A concentration wherein it's relatively equal all throughout. As long as you don't change the dose, the dosing frequency, and whatever. Okay, wala tayong babaguing parameter dito. So anyway, what about, class, when you compute for C max 3? So kanina ito, C max 1, C max 2, C max 3. Ito si C min 1, C min 2, saka C min 3. Now, class, sabi natin kanina, di ba si C max 2 is just C max 1 plus C min 1. So, ibig sabihin, whatever the height of this, dagdag mo lang sa height na na-produce nito, you get C max 2 here. So, when you get C max 3, class, it's just C max 1 plus C min 2. Okay, so whatever the height of this one is, plus yung height nito, will result to C max 3. Alright, makes sense naman, right? Now, to get C min 2, the equation for that, class, is C max 2 equal E negative K tau. So, pretty much the same lang din ng C min 1. Si C min 1 kasi, C max 1, E negative K tau. So, obviously, si C min 2 would be C max 2, E negative K tau. Okay? Now, if you resubstitute the formula here, pasok natin to. Dahil C min 2 yan, C min 2. So, therefore, class, C max 3 equals C max 1 plus C max 2 E negative K tau. Makes sense. Class, sabihin natin hindi mo alam si C max 2. Okay, sabihin natin hindi natin alam si C max 2. We can still compute for C max 2 as long as we know C max 1. So, very important na parameter dito, class, ay ang alam natin dapat yung C max 1 natin. Okay, and again, we can compute C max 1 using dose over VD. Yun na lang. Okay, kasi yun naman ang ginagamit natin clinically. Alright? So, therefore, class, resubstitute the equation here. Okay, for C max 2 would be this one. So, C max 1, C max 3 equals C max 1 plus C max 1 times 1 plus E negative K tau, E raised to negative K tau. Okay, ito yun eh. So, dito yan. Tapos ito yun. Okay? So, therefore, class, again, we can still rearrange and simplify this formula further. Ang lalabas, class, is C max 3 equals C max 1 times 1 plus E negative K tau times E negative K tau plus 1. Okay, sa algebra to. Now, class, again, further simplify the formula, we get this equation here. Okay, C max 3 equals C max 1. Nire-arrange ko lang to, So, inayos natin. So, 1 plus E negative K tau plus E negative 2 K tau. Alright? That's C max 3. Now, what if I give it multiple times? So, therefore, class, what if I give the drug 100 times. 100 doses, kunwari. So, ang lalabas yan, class, would be C max 1 plus 1 plus E negative K tau plus E negative 2 K tau plus E negative 3 K tau plus E negative 4 K tau hanggang 99 yun. Alright? Hanggang 99. Right? Or until whatever here. Okay? Yung N natin na K tau. Alright? So, you might be thinking, shucks, sir, ang hirap pala niyan, ang haba. Okay? Wala ba tayong Excel file niyan, sir? Okay, meron akong Excel file for bolus dosing, pero the thing is it's designed for clinical situations. Okay? Hindi siya applicable for the basic concept lang muna. Okay, kasi ito mamanipulate pa natin yung formula. Okay? So sa awa ng Diyos, class, tinatakot ko lang kayo sa equation na to. Actually meron namang summarized equation. Okay, which is if you give the drug multiple times, we can use the equation C max N. So kung ilang beses binigay yung dose is equal to C max 1 times 1 minus E negative N K tau over 1 minus E negative K tau. This is tau. Okay, hanggang ngayon hindi ko pa rin siya nako-correct. I'm so sorry. So that's C max N equals C max 1 is 1 minus E negative N K tau over 1 minus E negative K tau. Okay, now if you're looking, class, for C min N, that's C max 1 times 1 minus E negative N K tau over 1 minus E negative K tau times E raised to negative K tau. Alright? Now, you might be wondering, class, what is this? Ano itong dinagdag ko dito? Ano yan, sir, yung 1 minus E negative N K tau over 1 minus E negative K tau? This is actually, class, what we call the accumulation factor. Okay? It's called the accumulation factor. It is what we need, class, to determine how much of the drug will accumulate with respect to the dosing interval. And how many times are you going to give the drug? Okay? Kasi as you all know, class, if we give a drug multiple times, okay, then it will indeed, class, accumulate. So therefore, class, it's important that we insert here the accumulation factor. Because again, we'll be given the drug multiple times. And this equation here, class, is actually the same equation for C equals COE negative KT. Yun nga lang, class, ang CO natin here, di ba sabi natin kanina, CP sub 0 is equal to your C max 1. Okay, pero if you give the drug multiple times, then it has to accumulate. So therefore, nagdagdag lang tayo dito ng accumulation factor sa CP sub 0 natin here. Tapos E negative KT. Okay, so therefore, class, ang nangyari lang yan, okay, yan, at yan. Okay, it's just the same. Tapos ito naman, E negative K tau is the same as this one. E negative KT. Nga lang yung T ko here, instead of any time in the line, I made sure it's your dosing interval or your tau. Okay? So class, C min 1, or C min, sabi nga natin, is equal to C max times 1 minus E negative NKT over 1 minus E negative K tau times E negative K tau. Now, as I mentioned a while ago, ang C max 1 natin here can be expressed as dose over VD. Alright? So therefore, class, we can rearrange the formula. Okay, we insert the equation for C max 1 as dose over VD. Okay? Then same thing. Accumulation factor times E negative K tau. Okay, so yun nga, sabi natin, this is the accumulation factor. Now, let's try to have here, class, a sample problem. Okay? So, compute for the accumulation factor if 100 doses of a certain drug are given to a patient where K is 0.05 per hour and tau is 8 hours. Okay, so sabi natin, class, accumulation factor is equal to 1 minus E negative N K tau over 1 minus E negative K tau. Alright, so ang given natin here would be, sulat ko na nga lang, given N equals 100 doses. Okay, meron din 2 dose, and 2, and 1, and 3. Then 3 dose. Tapos ang K natin is 0.05 per hour, and our tau is 8 hours. Alright, so substitute the formula. 1 minus E negative 100 times K, which is 0.05, times tau, which is 8 hours. Okay, class, just make sure, ha, yung K at saka yung tau nyo, same ang unit. Alright? So, in this case, 0.05 per hour. Kasi tau ko is hour. Para mag-cancel out sila. Kasi hindi ko na isusulat yung dito. Hindi ko na isusulat yung units. Then 1 minus E negative 0.05 times E. Ang kalalabasan yan would be unahin mo natin to. 100 times 0.05 times 8 equals 40. So shift LN negative 40. You get 1 minus 8 ito 0.1 oh my gosh, 18 pala to. 4.248354 times 10 to the negative 18. Yun na lang. Kaya parang tayo mahirapan. Over 1 minus, mamaya na yan. Hindi. Ba't ko pa mamaya? 1. You can do this class ng, dire-diretso na. Okay, again, ang purpose ko dito is, isa-isahin natin. Okay, so 0.05 times 8 times, ay, na-off ko, ano ba yan? So, 0.05 times 8, shift LN, negative answer, kalalabasan is 1 minus 0.6703. Wait lang ha, just to make sure lang. 100 times 0.05 times 8, shift negative answer. Okay, tama ko. So, class, ang kalalabasan nito is 1 minus 4.248354 times 10 to the negative 8 would give you 1. Okay, then 1 minus 0.6703 would give us 0.3297. At ang kalalabasan ay 1 divided by answer. It's going to give you 3.03. So, yung AF for 100 doses, okay, 100 doses would be 3.303. What about yung accumulation factor for 2 doses? So, paano yun? So, we just do the same thing naman, class. Okay? So, here, 1 minus E negative 2 times 0.05 times 8 over 1 minus E negative 0.05 times 8. At ang kalalabasan ay 2 times 0.05 times 8. Shift LN. So, E negative answer 1 minus 0.4493 over, class, alam ko na kasi kalalabasan ito, this will be 1 minus 0.6703. Kasi same lang naman to sa denominator nito at saka nito. Okay, so 1 minus answer. Kalalabasan is 0.5507 over 0.3297. 3297. At ang kalalabasan ay 1.67. This is for 2 doses. What about accumulation factor for 3 doses? Negative 3, 0.05 times 8 over 1 minus E negative 0.05 times 8 equals, same lang ito, 1 minus 0.6703. 3 times 0.05 times 8. Shift LN, negative answer. 1 minus 0.3012. That's answer. 0.6988 divided by 0.3297. 3297. Kalalabasan ay 2.11. This is after 3 doses. So class, what have you noticed? Okay, one thing you'll notice, class, is as we increase the number of doses, oops, nakaharang pala ang aking camera. Oh no, hindi ko siya nagalaw. Anyway, basta ang sagot, class, sa accumulation factor for 2 doses would be 1.67, and then for 3 doses ay 2.11. Alright? So class, one thing you'll notice with the accumulation factor is as you increase the number of doses, class, tumataas yung accumulation factor. Okay? Now class, if you reach a certain threshold, a certain number of doses, you'll notice one thing, class. Okay, let's say for example, ito accumulation factor at 100. Try nyo, class, at 1,000 doses. Okay? Even if you put here, class, 1,000, 100,000, 1 million, laging lalabas na numerator mo, class, is 1. That indicates kasi, class, that the drug is already at steady state. Kumbaga, based on the number of doses given, okay, once na 1 na lang, class, ang lumalabas na numerator, it indicates that the drug is at steady state already. Okay? Steady state na yan. So, ibig sabihin, kahit gaano karami pang dose ang bibigay mo, wala na, steady state yan. So, accumulation factor will remain the same. 3.03 yan for this drug here. Right? Okay. That's the reason why, class, what happens to accumulation factor once you already reach the steady state concentrations? At steady state concentration, class, yung numerator natin nagiging 1 na lang. Okay? No need to write this all down if you know that the drug is already at steady state. Or kung magko-compute ka ng dose kung saan ang goal mo ay nasa steady state na dapat yung concentration. Alright? Yeah. Kaya, class, the C peak at steady state, okay, if you want to determine, di ba kanina, yung ganito. Ganun. If you want to know, class, the C peaks here, the C mean, halimbawa the C mean N or the C max N, then, class, ito yung mga formula na gagamitin natin. For C mean N, ito yon. Alright? Pero, class, kung ang hanap na natin ay ang C peak, ito na. This guy here. Palitan natin ng kulay. You want to determine, oops, ay, ayan. C peak SS. Okay? If you want to determine this, class, then ang formula na gagamitin natin is this one. Of course, class, mas relevant yung formula na to because ano ba ang goal natin here? Ba't tayo nabibigay ng multiple dosing? Ang goal natin here is to make sure that the drug accumulates. Okay, yun yung goal natin here eh. Right? So, kumbaga, pag nakuha mo na yung C-peak SS yan, itong C-peak na to, ito, at saka mga succeeding peaks, class, will be the same. Nagbabago lang yan before C-peak SS. Okay? Nag-iiba-iba, pa-increasing increments. Alright? So, anyway, class, for the formula for C-peak SS or C-peak steady state, the formula will be dose over VD or C max 1, okay, over 1 times 1 minus E negative K tau. Alright? Or the accumulation factor at steady state. Okay? So, yun. Now, kung C trough naman at steady state, so if you're looking for the C trough here, SS, or what we call the C mean SS, okay, or C trough steady state. So, the same formula, class, C max times E negative K tau. Yun lang naman pinagkaiba ng C peak sa C mean. Ang peak, walang E negative K tau. Okay, ang C trough, or ang C mean, SS, may E negative K tau, which is, again, derived from the formula C equals CO E negative KT. Itong CO na yan is this entire formula here. Okay, kaya lang naman natin ito pinasok yung side na to because we're giving it multiple times and the drug is accumulating. So, parang XO over VD times E negative KT. Does that make sense? Yun nga lang, since alam ko naman kasi ang mean ko will always be after the dosing interval. Kaya ginagawa natin is tau na lang. Okay? I hope that makes sense. So C trough occurs just before the administration of the next dose at T. So therefore, T will be equal to tau. Okay? So as long as the drug class is here, sa aspect na to, okay, increasing pa yan. Alright? Increasing pa yung ating Cmax. Okay, pero once na-reach na itong side na to, sabi natin, it's already at steady state. And we want the drug class to reach steady state concentrations that is within the therapeutic window. Because as long as the drug is in the therapeutic window, we assume that the drug is both safe and effective. Okay? Yeah. Let's have another sample problem here, class. Okay, if Cmax 1, K, and tau are 100 milligrams per liter, 0.4 per hour, and 6 hours, respectively, what is the value of Cmax 2? Now, we can do this two ways. As long as I know the Cmax, kukumpit ko muna Cmax 1, okay, using the equation for so yun. Okay, isang equation natin. Pero syempre, class, medyo tamad na tayo. Ayoko naman kayong pahirapan din. Okay? So, ang gagawin natin, classes, gagamitin natin yung formula ng may accumulation factor na. So, ba't ba natin pahihirapan, right? Okay. So, therefore, suot natin ang given. Cmax 1 is equal to 100 milligrams per liter. K is equal to 0.4 per hour. And then the dosing interval, so tau, is equivalent to 6 hours. So, ang required natin ay Cmax 2 at saka Cmin 2. So, solution. Dito tayo magsuot ng solution. Okay, baka matakpan na naman ng video ko. So, di ba class, ang equation natin for Cmax Cmax n is equal to Cmax 1 times 1 minus E negative N K tau over 1 minus E negative K tau. Yun. So, therefore, ang Cmax 1 ko is 100. So, kasi ko naman naisuot yung mga yung mga units. Okay, pero kasi, here pa naman, alam naman natin na cancelable naman na yung hours natin. Okay, pero sige na nga, sulat na natin. Milligram per liter. Times 1 minus, 1 minus E negative Cmax 2. So, ibig sabihin, 2 doses. 2 times, ang K natin is 0.4 times, ang tau natin ay 6. Okay, over 1 minus E negative 0.4 times 6. Yan. Okay. So, ang kalalabasan nito ay 100 milligrams per liter times 1 minus 2 times 0.4 times 6. Shift ln negative answer. 1 times 8.29 2297 times 10 to the negative 3. Okay. Sorry, unahin ko lang ito saglit para hindi lang ako malito. Kasi alam ko naman gagawin. Ito pa naman kalalabasan 1 minus answer 0.9918. Alright. So, dito naman sa denominator, 1 minus 0.4 times 6. Shift relative answer 0.0907. 1 minus answer 0.9093. So 100 akala ko napuno na ako. Di pa naman 100 milligram per liter times 0.9918 divided by answer 1.0908. And therefore, Cmax 2 is equal to times 100. 109.07. 08 pala. 8 milligrams per liter. Alright. Okay. So, yun siya. Or, sabi nga dito, sa option natin, ito magiging sagot natin. 109.1 milligram per liter. Okay, that's Cmax 2. Now, how do you get Cmin 2? Okay? Diba ang Cmin 2 lang naman kasi is Cmax 2 times E negative K tau. And that's 109.1 times E raised to negative 0.04 times tau, which is 6. .4 times 6. Shift LN negative answer. Okay. That's 109.1 times 0.0907 equals times 109.1. 109.1. Yes, FM. 9.8973 milligrams per liter, or sabi nga natin class, that would be 9.9 milligrams per liter. This would be the correct answer. Alright? Okay, so that's how we use class the equation here. Now, of course, kung ilang doses yun, depende na sa atin. Pwedeng after 3 doses, ano yung Cmax, after 4 doses, after 1,000 doses, whatever. Alright? As long as the drug class is given intravenously, ito lang yung gagamitin nating equation. Intravenously, bolus. Alright? Kasi ito yung pinakamadaling maintindihan. Okay? So let's have a follow-up to that problem. So what is the Cmax concentration after 15 doses if the dose is 800 milligrams and the volume distribution is 20 liters? Now this time we're not given Cmax. Okay, but we are on the other hand given a dose and the VD. May nag-question nga pala before. Okay, one of you students question before. Ano pinagkaiba ng, iba ro kasi ang use ng milligram per liter sa microgram per ml. Actually, class, they're just the same. Kasi if you notice, ang conversion factor ng both milligrams to micrograms and liters to ml is 1,000. Okay? So, 1,000 divided by 1,000. So, the same lang siya. So, if I express class my concentration as, say for example, 10 milligrams per liter, that's the same as saying it's 10 microgram per ml. Alright? One ang kanilang conversion factor. Right? So, just so you know. Kasi oftentimes, class, when we express plasma concentration, it's usually expressed as micrograms per ml. Mga doses natin in milligrams, di ba? So, wag na kayong magpakahirap, class. Kung naka-microgram per ml na yan, convert nyo na lang to milligram per liter. Same lang yun. 1:1 lang naman ang conversion factor. Anyway, so what is the max concentration after 15 doses if the dose is 800 milligrams and the VD is 20 liters? Assume that tau equals 6 hours and K equals 0.5 hours. Alright? So here, class, you have the given dose, which is 800 milligrams. VD, which is equal to 20 liters. Tau, which is equal to 6 hours. And then K, which is equal to 0.5 hours. Per hour. Per hour. Right? Ang required natin ay Cmax 15 equals unknown after 15 doses daw. So, solution. Okay, so Cmax 15 is equivalent to Gagamit ng formula class would be dose over VD. Yun yung pamalit natin for Cmax, right? Times 1 minus E negative N K tau over 1 minus E negative K tau. Cmax na naman hinihingi, right? Okay. Yun Cmin. So dose is 800 milligrams divided by 20 liters times 1 minus E negative 15 times K, which is 0.5 times tau, which is 6 hours over 1 minus E negative 0.5 times 6. Kasya pa? Kasya. 800 divided by 20 liters, 40. Okay, times 1 minus 15 times 0.5 times 6. Shift ln, negative answer. Ha! Times 2.86 times 10 to the negative 20. Alam ko nakalalabasan yan. Pero try natin. Okay. 40. 1 minus answer. Knew it. Lalabas yan ay 1. Anyway, 0.5 times 6 equals negative answer. 0.0498. 1 minus answer 0.9502 equals, dito na tayo, 40 milligrams per liter times 1 divided by answer. It's 1.0524 times 40, you get 42.0958 milligrams per liter. Or if we round it off class, that gives us 42.1 milligrams per liter. Alright? Yun. Okay, now class. It's quite easy, right? It's quite easy to use. Pero what if dumating ang panahon, I'll be asking you guys to compute for, say for example, dose. Okay, dose na ibibigay mo if the drug is at steady state. Okay, then obviously class, you have to transpose the entire formula. Or what if I ask for tau? Okay, what would be the perfect dosing interval for a drug whose dose is ganito and its VD is ganito with a half-life of ganyan to get your K? Okay, yun na kasi magiging clinical applications nito. Okay, pero sabi ko nga, for now, let's just stick muna with the basic concepts. Okay, let's stick to the basic formula muna. Next time natin gawin medyo lang naman komplikado. Okay, pero yun kasi yung may application clinically. Okay? Okay, now class, if you have concentration the concentration at any given time after getting the C peak, steady state can be determined, right? Normally, class, if you want to determine the concentration after C peak has been reached, then all you need to do is get the C peak concentration, C peak SS, times E negative KT. Yung T wherein the time na gusto mong malaman yung concentration. Okay, which is similar to the equation C equals COE negative KT. Okay, so ibig sabihin, class, if I wish, say for example, this is already C peak. Okay, pinalitan ko pala to. Kunwari ito ay, takpan natin yan ha. Ito ay C peak SS. Kunwari lang. Okay, ganyan na siya. If I want to get, let's say for example, guys, this is every 8 hours. That's every 8 hours. 16 hour. Halimbawa, gusto ko malaman yung time from this point to this point. Sabihin natin na nag-lapse dyan ay 4 hours. Okay, after 4 hours. Alright? So, yung T na gagamitin ko dyan, class, would be, alam kong this should be 8, 9, 10, 11, 12. This is 12 hours, right? After 12 hours. Pero 4 hours na kasi nag-lapse from C peak to this concentration here. So CP on the 12th hour. Okay? Hindi ko ilalagay dyan kasi na T is 12 hours. Kasi ang nag-lapse lang from peak to CP12 is 4 hours. Does that make sense? From here to here, ang nag-lapse na time, sabi ko nga, is 4 hours. Pero this is the plasma concentration on the 12th hour. Alright? 12th hour. Let's say, for example. So, kung ko-compute ko yan, class, gusto ko malaman. Alam ba, trip-trip ko lang. Gusto ko lang malaman. Ano kaya ang concentration ng patient ko after ano? After 4 hours has lapsed since I last gave the dose. Okay? Pwede mo malaman yun. Basta nasa peak concentration na yung drug mo. Or alam mo yung peak concentration mo. So, therefore, kasi ang magiging formula lang yan would be C12. Okay, CP12 is equal to C peak SS times E negative K. Ang T na gagamitin mo dito, class, is 4. Normally, class, ang T here is usually, basta, this T here, class, will always be your lapse time. Okay, the time that has lapsed. Ibahin natin yung kulay para mapansin. Okay, so yung 4 hours natin here is the lapse time from peak SS, C peak SS to CP12. Alright? So I hope that makes sense. So yun yung magiging equation ko dyan. Or yun yung magiging formula ko. Okay? Now, what about average steady state concentration? How do we compute for that? One thing kasi, class, na mapapansin natin is that if you give the drug via bolus, ang lalaki ng difference or gaps between the peaks and trough concentration. The peaks, the C peak and the C mean, malalaki yung gaps. Okay, unlike, class, if I give this via infusion, kung infusion yan kasi ang lalabas dyan, parang ito lang. Halos wala ka na makikita ang peaks and trough. Kasi infusion yun eh. Tuloy-tuloy lang yung pagbigay. If I give this intermittent infusion, well, may makikita akong difference in peaks and trough. Pero generally speaking, class, if you give that via IV bolus, ang lalaki ng difference between the peak and then the trough concentrations. Okay? So, it's ideal, pag ganito ang scenario, class, masyado malaki ang difference ng peak and trough concentration, kunin na lang natin yung average. Now, class, yung pagkuha ng average is not as simple as C max, C peak plus C min, C peak SS plus C min SS divided by 2. No, it's not as simple as that. Okay? So you have to get the median of this amount, of the peak and the trough. And normally, class, this is applicable for drugs having long half-lives, in which the difference between the peak and trough steady state levels may not be that large. Okay? So, when we compute, class, for steady state concentrations, usually it's just AUC over tau. Okay? Now, AUC, in terms of AUC, class, remember, this is equivalent to 1 dose, right? This is 1 dose. Okay? So, yung katabi niya is another dose. Right? And it's another dose. And diba when we compute AUC, I just need to get this. Okay? And kung nasa peak concentration naman na yung ano ko, yung gamot ko, okay, if it's already in peak concentrations, so yung AUC nito, area na to, is the same as the AUC of this one and the AUC of this one. Correct? So pare-pareho na lang yan eh. Nasa peak concentrations ka na eh. Okay, so to get AUC, class, normally the formula for that is dose over clearance. You can still remember, class, dose given na yan. Kung anong dose na ginamit mo. Clearance has a formula of VDK. Okay, may VDK tayo na formula dyan. So, if you resubstitute the equation, class, ang lalabas dyan would be steady state concentration, average steady state. Sorry, I forgot to put here. That should be C bar. Okay, C bar yan. So, will be equal to dose over clearance times dosing interval. Okay? Yeah. So, when predicting steady state concentrations, okay, sabi nga natin, C peak for steady state is equal to dose over VD times 1 over 1 minus A negative K tau. Now, 1 na ito, class, because sabi nga natin, the drug is already at steady state. Okay? Now, oftentimes, class, ang kailangan lang natin na value here are K and V. Okay, which is usually derived from published reports. How do I get K, class? How do I get K? Normally, class, in any drug literature, T1/2 will always be provided. Okay, your half-life will always be provided. And remember, class, the equation for K? Ano equation natin for K? That's 0.693 divided by half-life. So, meaning, class, you can always get your K as long as you have the drug's half-life. And provided that the drug is following first-order kinetics and it follows one compartment model. Ano pala dapat i-consider, no? Okay, pero really lang, class, most drugs naman follow first-order kinetics and they follow one compartment model. Ilan lang naman yung gamot na hindi. Alright? Yeah. And then, of course, kasi ang VD, sabi ko sa inyo, provided naman to lagi sa drug lit. Now, say for example, class, if a patient receives 500 milligrams of drug X intravenously every 6 hours until steady state is reached. Now, just after the dose is administered, a blood sample is drawn to determine the peak plasma concentration. Then, 5 hours later, a second plasma concentration is derived. Now, here's the thing, class. If you're given 2 plasma concentrations, halimbawa, matyaga yung doktor, gusto niya ay magpasample ng blood sa patient 2 times. 2 times. So, if you have 2 plasma concentrations, class, you can compute for K. No need to get the drug's half-life. Pero kung tinatamad ka, sige, gamitin mo lang yung drug's half-life. Pero if you want to get, class, the actual elimination rate constant of the drug for that specific patient, then it's ideal, class, that you compute for your K. The K of that patient themselves. Yung K mismo nila. And how do we compute for K, class? If you still remember, K is equal to ln C1 minus ln C2 over T2 minus T1. So in this case, I can compute for my K. Ano yun? K equals, anong ln C1 ko? Peak plasma concentration, right? So ln C peak SS minus ln C5, kasi after 5 hours yun. So that would be 5 hours na lang here. Oh, sorry. Would be T, which is 5 hours. Now, class, ang C-peak natin, remember, the C-peak will always be 0. I mean, yung time niya would be equivalent to 0. Pero kung gusto mo talagang, ibahin, okay, halimbawa, C-peak was derived, kunwari lang to, okay, peak plasma concentration was taken on the 12th hour. Then, 5 hours later, so that would be, ang C5 natin will be on the 17th hour. So, gagawin mo lang dyan, class, would be ln C peak minus ln C5 would be equal to 17 minus 12. Yun lang naman yun. 5 rin naman ang lalabas dyan. Basta kasalanan nyo, ang tinitingnan natin dito is the lapse time. What's the time that has lapsed from peak concentration to your desired plasma concentration? In this case, C5 ang gusto natin. So, ibig sabihin, 5 hours have lapsed. Okay? At sinabi naman sa problem, then 5 hours later, meaning from peak to your desired plasma concentration, na-determine natin na 5 hours ang lapse. Okay? Then, you can compute now for your K. So, normally, class, the first step is to determine your K using 2 plasma concentration given. So, again, C peak, ln C peak minus ln C5 divided by 5. Okay? 5 hours after the C peak. Next one is to derive your volume of distribution from the given formula. So now, class, if you rearrange the equation, okay, we rearrange the formula, ang lalabas dyan, class, would be VD equals dose over C peak, okay, times 1 minus E negative K tau. Remember, this is the accumulation factor. This is steady state AF. Alright, if you get the VD. Now, sabi ko nga sa inyo, VD can be taken from published literatures, pero mas maganda pag kinumpute mo ang VD ng patient mo mismo. Right? And then, after you get the K and the VD, we can now calculate for a new C peak if we change the dose. Okay? Such as if the previous C peak is too high or too low. So, determine the dose based on you can also determine the dose based on the desired C peak. And note, as long as VD and K does not change with dose or C peak. Okay? So normally, class, we can compute for this using the following formula. So if you want to compute the dose, okay, if you want to compute the dose, class, given ka ng desired peak concentration mo, and you know the VD, you know the dosing interval, and you know the K, then you can use this formula here to compute for dose. Okay, so halimbawa, ibigay pa ba tayong halimbawa? O kunwari, let's give a sample problem here. Okay, drug X ulit. Ang kanyang VD is kunwari 20 liters based on literature, ha? Kunwari na multiply natin sa patient weight. Then ang desired CPSS is 10 milligrams per liter. Dosing interval is sabihin natin 8 hours. Okay? Sabihin natin ang half-life is 5 hours. Kunwari lang naman. Okay? Kasi ito yung mga available sa drug list. Kunwari tayo na-compute. I mean, ayoko nang i-compute pa na yung actual VD, actual K. Pero kung of course, given ka naman data class, just compute for it. Alright, so half-life niya is 5. So that's 0.693 divided by 5. Ang K ko, solution, K equals 0.693 divided by half-life. And that gives me 0.1386 per hour. That's for my K. Now, given the scenario, class, okay, ang desired plasma concentration is 10 milligrams per liter. Drugs VD is 20 liters. Dosing intervals is 8 hours. And then the K is 0.1386. Determine the dose. I can determine that using this formula. So that's just dose equals 20 liters times 10 milligram per liter. Cancel na to. Okay, times 1 minus E, negative 0.1386 times 8. So 20 times 10, well, 200. 200 times 1 minus 0.1386 times 8. LN, negative answer, minus 0.32995. So 1 minus answer equals 200 times 0.6700 times 200. You get 134 milligrams. So class, if my patient has, if my drug X has a CPSS of 10 milligrams per liter, desired, ito yung desired plasma concentration ko, I'll give my dose 134 milligrams. Pwede ko i-round up, round down, depende sa available na dose. Okay, but I can give that as 134 milligrams. Okay? Or you can choose a new dose and calculate the resulting C peak. So determine the C peak based on dose given. Alright? So C peak here, we have the dose over VD times the accumulation factor for steady state. So you can just apply here, class, the formula. Okay? Alright. So remember that each time we calculate a peak plasma concentration, the trough plasma concentration can also be computed. So the trough would be C peak equals E negative K tau. Okay, if the dosing interval is not changed, a new dose and concentrations are directly proportional if nothing else will change. Okay, so therefore, class, basta provided that the K and the VD will not change for whatever reason. Okay, kasi usually ang K, class, nagbabago pag may renal failure ang patient. Biglang nag-progress yung renal failure, nagkaroon ng liver problem. Ang VD nagbabago, class, if suddenly the patient becomes edematous or meron siyang congestive heart failure or may edema yung patient natin. So nagbabago yung VD ng patient throughout the course ng course niya sa hospital. Okay, pero kung hindi magbabago yung class, assuming the patient is relatively healthy, yung kanyang kidney, hindi naman siya, wala namang CHF, walang edematous, hindi siya edematous. Okay, then class, we can perform this ratio and proportion na lang. Wherein if you want to determine, class, a new dose, all you need is ano ba yung desired mo na new, or what we call the desired CPSS. Okay, then yung dating CPSS na meron ka, your old, then multiply to the dose na ginamit mo that led to this CPSS. Okay? Yun ay kung gusto mo lang palitan yung, tawag dito, magpapalit ka ng dose. Kasi halimbawa, yung old dose mo led to a much higher plasma concentration. So gusto mo mas mababa. So yung new mo here would be mas mababang dose, mas mababang concentration. Then, lagay mo na lang dito yung ano yung original CPSS niya at saka yung dose na ginamit niya to compute for a new dose. Okay? Alright.